Scipy, linear programming with sparse matrices. I want to solve a linear program in Python. The number of variables, I will call it n from now on, is very large, ~5000, and in order to formulate the problem in the way scipy.optimize.linprog requires it, I have to construct two n(x)n matrices, A and B below. The LP can be written as where by dot denotes the dot product and A, B, and C are vectors with length n. My experience is that constructing such large matrices, A and B have both approximately 50,000 by 50,000 equals 25 times 10 to the power of 8 entries, comes with some issues. If the hardware is not very strong, NumPy may refuse to construct such big matrices at all. See for example very large matrices using Python and NumPy, and even if NumPy creates the matrix without problems, there is a huge performance issue. This is natural regarding the huge amount of data NumPy has to deal with. However, even though my linear program comes with n variables, the matrices I work with are very sparse. One of them has only entries in the very first row, the other one only in the first m rows, with n/2. Of course I would like to exploit this fact. As far as I have read, for example trying to solve a Scipy optimization problem using sparse matrices and failing, scipy.optimize.linprog does not work with sparse matrices. Therefore, I have the following questions. Is it actually true that Scipy does not offer any possibility to solve a linear program with sparse matrices? If not, how can I do it? Do you know any alternative library that will solve the problem more effectively than Scipy with non-sparse matrices? The library suggested in the thread above seems to be not flexible enough for my purposes, as far as I understand its documentation. Can it be expected that a new implementation of the simplex algorithm, using plain Python, no C, that exploits the sparsity of the matrices will be more efficient than Scipy with non-sparse matrices?
I would say forming a dense matrix, or two, to solve a large sparse LP is probably not the right thing to do. When solving a large sparse LP, it is important to use a solver that has facilities to handle such problems and also to generate the model in a way that does not create explicitly any of these zero elements. Writing a stable, fast, sparse simplex LP solver in Python as a replacement for the Scipy dense solver is not a trivial exercise. Moreover, a solver written in pure Python may not perform as well. For the size you indicate, although not very large, maybe large medium-sized model would be a good classification. You may want to consider a commercial solver like Plex, Gurobi or Mosaic. These solvers are very fast and very reliable. They solve basically any LP problem you throw at them. They all have Python APIs. The solvers are free or very cheap for academics. If you want to use an open source solver, you may want to look at the CoinCLP solver. It also has a Python interface. If your model is more complex, then you also may want to consider to use a Python modeling tool such as Pop or Pyomo. Gurobi also has good modeling support in Python.
I can't believe nobody has pointed you in the direction of pulp. You will be able to create your problem efficiently, like so. Pulp is fantastic, comes with a very decent solver, CBC, and can be hooked up to open source and commercial solvers. I am currently using it in production for a forestry company and exploring Dippy for the hardest, integer, problems we have. Best of luck.
If you want to see more, please consider subscribing.